Hey guys, my name is Parth and I'm a rising senior at Mission San Jose High School. And my main project is the running glasses. And the running glasses are essentially supposed to give you the mileage and the pace at which you're running. And I implemented these glasses as an effort to solve problems I was facing while running cross country and track. So when I was trying to figure out how fast I was running and maintain a constant pace, I often had to look at my phone or look at a certain tracker, and this would often result in safety issues or concentration issues, which would hurt my performance. So in an effort to solve that, I made these, and I'll give you a quick demo. So currently the acceleration or the velocity would be at 0, and if I moved it quickly, it would result in a spike in the velocity, and then it would come back to 0, and then the same thing if I would move it backwards. So this would essentially give you the speed at any point while which you are running. How does this exactly work? So for this project, for this part of the project, I used an Arduino Nano and an accelerometer, and I connected them using an I2C bus, which essentially allowed the Arduino Nano to be a master and the accelerometer to be the slave, and convey data and information between the two. So I used that, and then I used a library that allowed me to essentially get the data I wanted for the x-axis from the accelerometer, and I also used a simple algorithm to try and figure out the velocity from the accelerometer. So since Arduino didn't have a built-in function to essentially integrate the acceleration and give me the velocity, I used a Riemann sum and took small intervals and used a midpoint sum by averaging the two sides of those intervals, and found the area under the curve to find the velocity of the object at any point in time. In terms of what I exactly learned from this was I learned how to use an Arduino Nano, an accelerometer, and how to connect them, how to use an I2C bus, and essentially how to use libraries to program and derive certain information from the accelerometer. So I faced many difficulties during this. I faced three main difficulties. The first one would be trying to figure out why the accelerometer and Nano weren't working well together and why the data wasn't being transferred well. And I realized this was simply because the breadboard wasn't working and wasn't sufficing, and I essentially just soldered them and tried to get, and it worked. The second problem I faced was that the libraries that I was using weren't as accurate as I wanted them to be. So I went through 4 libraries, and I realized that if I wanted a more accurate library, it tended to be harder to use, and if I wanted a simpler library, it wasn't as accurate, and obviously it was easier, but it wouldn't suffice for what I wanted to do. So I used one of the harder libraries, and I ended up figuring out that it was in meters per second squared. The information it gave me, so that was pretty useful too. Then the last problem I faced was that the accelerometers in general tend to give you a certain amount of error that's hard to account for. So even if they're high end, they give you that amount of error, and you have to try to figure out how to account for it. So my accelerometer continually gave me 2 types of errors. The first one was due to gravity. So if it was tilted, it would also measure the force due to gravity, which would essentially add acceleration I didn't want it to. So I had to figure out that error and subtract it from the actual acceleration I was facing. And then the second thing I had to figure out was why exactly how to exactly use the acceleration in the way I wanted it to be. Often I would get small values, but since I was adding those small values over time, it would give me a velocity that really didn't make any sense. So I tried to figure out and take out outliers or values that were of actual no use to me. So for the next milestone, I'm going to use an OLED display, and thanks for watching.